Have you ever wondered why DNA testing companies can identify Jewish ancestry? It seems strange, doesn't it? How can a religion show up in your genetic code? After all, people of the same faith living in different corners of the world should have wildly different DNA based on their geography, right? What makes Jewish ancestry detectable in a way that, say, Christian or Buddhist ancestry isn't? This is where the story gets fascinating. Jewish ancestry appears in DNA tests not because Judaism left a mark on people's genes, religions don't alter DNA, but because certain Jewish populations became genetically distinct through a combination of geography, history, culture, and marriage practices that kept these communities somewhat genetically isolated over centuries. To understand this genetic story, we need to travel back thousands of years to the ancient Middle East, where the Jewish story began. The earliest historical references to the people who would become known as Jews appear in ancient Egyptian texts from around 1200 BC, where they are called Israelites. Biblical tradition traces their origins to Abraham, who supposedly lived around 1800 BC in Mesopotamia before migrating to Canaan, roughly modern-day Israel. These early Israelites weren't genetically distinct from their neighbors at first. They were simply one of many Semitic-speaking peoples in the region, closely related to Canaanites, early Phoenicians, and other local populations. What set them apart was their emerging monotheistic religion and unique cultural practices, not their genetics. Archaeological evidence confirms these ancient Israelites built a kingdom centered around Jerusalem, which eventually split into the kingdoms of Israel and Judah. It was from Judah that the word Jew would eventually derive. When the Babylonian Empire conquered Judah in 586 BC, they exiled many residents to Babylon, the first major displacement of Jewish people that would characterize much of their subsequent history. But what was their genetic makeup at this time? Modern genetic studies suggest these ancient Israelites carried Y chromosome haplogroups common to the Levant region, particularly J1 and J2, which remain prevalent among both Jewish and non-Jewish Middle Eastern populations today. Their mitochondrial DNA, passed exclusively from mothers to children, likely included haplogroups common to the region as well, including subgroups of haplogroups H, K, and others still found throughout the Mediterranean and Middle East. When some exiled Jews returned to rebuild Jerusalem under Persian rule, they maintained stronger boundaries around their community. The scribe Ezra reportedly forbade intermarriage with surrounding peoples, setting a precedent for the endogamy, marriage within the community, that would later play such an important role in Jewish genetic distinctiveness. After Alexander the Great's conquests spread Hellenistic culture throughout the region, many Jews dispersed throughout the Mediterranean world, establishing communities in Egypt, Syria, Greece, and beyond. Romans called this population the diaspora, from Greek for scattering. When the Romans destroyed the Second Temple in Jerusalem in 70 AD, following a Jewish revolt, even more Jews were displaced, accelerating this dispersion. Yet despite living among diverse populations, many Jewish communities maintained their distinct religious practices and tended to marry within their faith. This wasn't absolute. Converts joined Jewish communities, and some Jews certainly had children with non-Jews, but the overall pattern of marrying within the community created the beginnings of genetic distinctiveness. As centuries passed, these dispersed Jewish populations developed into several major branches, with their own unique histories and genetic signatures. The three largest groups became known as Ashkanazi, Sephardic, and Mizrahi Jews. Mizrahi Jews remained closest to the ancestral homeland, living continuously in the Middle East and North Africa. Their genetic makeup shows the strongest connection to ancient Levantine populations, with relatively less admixture from surrounding peoples. Iraqi Jews, Iranian Jews, and Yemenite Jews all fall within this broad category, each with slight variations in their genetic profile reflecting their specific histories. Yemenite Jews, for instance, maintained an isolated community in the Arabian Peninsula for nearly 2,000 years. Their genetic studies reveal predominantly Middle Eastern ancestry, with some admixture from the local Arabian population. They carry unique genetic variants not found in other Jewish groups, yet still share certain key genetic markers that connect them to the broader Jewish diaspora. Sephardic Jews established themselves throughout the Mediterranean, particularly in the Iberian Peninsula, modern Spain and Portugal, where they lived for centuries. During this age, Jewish communities experienced some cultural and economic stability. The genetic story of Sephardic Jews reveals a fascinating mixture. They maintained significant genetic connections to Middle Eastern ancestry while also incorporating genetic influences from North African Berbers and various Mediterranean populations. When they were brutally expelled from Spain in 1492, these communities dispersed again throughout North Africa, the Ottoman Empire, Italy, and the Netherlands, carrying their unique genetic mixture with them. Perhaps the most genetically studied Jewish population is the Ashkanazi community, which formed in the Rhine Valley of France and Germany around 900 to 1000 AD, before later expanding eastward into Poland, Lithuania, Ukraine, and Russia. Their genetic story is particularly interesting because it involves several founder events and population bottlenecks that dramatically shape their genetic profile. A founder event occurs when a small group establishes a new population, bringing only a fraction of the genetic diversity from their parent population. Population bottlenecks happen when dramatic reductions in population size due to persecution, disease, or migration further restrict genetic diversity. The Ashkenazi population experienced both phenomena repeatedly throughout their history. As mentioned earlier, the genetic evidence suggests that the early Ashkenazi community began with just a few hundred individuals who migrated from southern Europe and the Middle East into the Rhine Valley. These founders carried only a subset of the genetic diversity present in the broader Jewish population. Studies of their mitochondrial DNA have revealed something surprising. While Ashkenazi paternal lineages, Y chromosome, show predominantly Middle Eastern origins similar to other Jewish communities, a significant portion of their maternal lineages appear to derive from European women who joined the community, likely through conversion. This doesn't mean, as some have claimed, that Ashkenazi Jews are actually European. Rather, it reflects the complex reality of population formation. The early male Jewish merchants and scholars who established communities in Europe often married local women who converted to Judaism, creating a population with mixed ancestry. As these early Ashkenazi communities grew, they faced repeated persecutions, including massacres during the Crusades, expulsions from various cities and regions, and restrictions that concentrated them in particular areas. As mentioned earlier, each of these events created genetic bottlenecks that reduced diversity and increased the frequency of certain genetic variants within the population. Particularly significant was the population restriction following the Black Death in the 14th century, when Jewish communities were often blamed for the plague and massacred. Those who survived faced increasing restrictions that confined them to specific areas, later formalized as ghettos, and limited their economic activities primarily to occupations like moneylending that Christians were forbidden to practice. Despite these hardships, the Ashkenazi population experienced remarkable growth during the 16th to 18th centuries, particularly in Eastern Europe. From a population of perhaps a few thousand in 1500, they grew to several million by 1900. As mentioned earlier, the practice of endogamy, marrying within the community, further reinforced these genetic patterns. While never absolute, conversion and intermarriage did occur like in other Jewish groups. The cultural practice of matching Jewish children with other Jewish families, combined with external factors like discrimination against interfaith marriages, meant that Ashkenazi Jews primarily had children with other Ashkenazi Jews, generation after generation. This created a unique genetic signature, distinct from surrounding European populations, despite centuries of living among them. This brings us to one of the most medically significant aspects of Jewish genetic history, the prevalence of certain genetic diseases. The combination of founder effects, population bottlenecks, and endogamy dramatically increased the frequency of certain genetic variants within specific Jewish populations. In Ashkenazi Jews, this led to higher rates of Tay-Sachs disease, Gaucher disease. Similarly, Sephardic Jews have elevated rates of familial Mediterranean fever, while Persian Jews show higher frequencies of mutations causing salt-wasting congenital adrenal hyperplasia. These disease patterns helped early genetic researchers identify distinctive Jewish genetic signatures, which became important reference points when modern consumer DNA testing emerged. Companies created reference panels based on people with known backgrounds, including Ashkenazi Jews, whose distinctive genetic patterns made them relatively easy to identify compared to many other populations. When your DNA test identifies Jewish ancestry, it's typically detecting genetic similarities to these reference populations. The test isn't identifying religious belief or practice, but rather genetic connections to these historical communities, shaped by a unique combination of geography, endogamy, founder effects, and population bottlenecks. Beyond the three major branches of Ashkenazi, Sephardic, and Mizrahi Jews, several other fascinating Jewish communities developed with their own genetic stories. One of the most interesting is the Beta Israel community of Ethiopia, whose origins remain somewhat mysterious. The Beta Israel practiced Judaism for centuries in isolation from other Jewish communities, developing distinct religious traditions while maintaining core Jewish practices. Genetically, however, they differ significantly from other Jewish populations. Their DNA primarily matches that of other Ethiopian populations, with perhaps a small component that might trace to ancient Middle Eastern ancestry. This suggests that the Beta Israel likely formed primarily through the conversion of local Ethiopians to Judaism, perhaps influenced by Jews who traveled from Yemen or Egypt in ancient times. Their story reminds us that Jewish identity has always been formed through both inheritance and choice, through both birth and conversion, creating communities that share religious and cultural practices even when they don't share substantial genetic ancestry. Similarly, the Bene Israel community in India has existed for at least 1,000 years along India's western coast. Their genetic analysis shows predominantly Indian ancestry, mixed with some signals of Middle Eastern heritage, suggesting a small group of Jewish merchants or refugees who settled in India and intermarried with the local population. Despite their genetic differences from other Jewish communities, they maintained Jewish religious practices for centuries in isolation. The Kaifeng Jews of China represent another fascinating case of a community that maintained Jewish practices for centuries, despite becoming genetically indistinguishable from the surrounding Chinese population. First established by Persian Jewish merchants traveling the Silk Road during the Song dynasty, the community gradually intermarried with local Chinese people while preserving Jewish religious practices. By the 19th century, when Western missionaries encountered them, they had maintained distinctive Jewish religious traditions despite being physically indistinguishable from their Chinese neighbours. These diverse communities demonstrate a crucial point. Jewish identity has never been solely defined by genetics. Throughout history, being Jewish has meant participating in a religious and cultural tradition, regardless of ancestral origins. At the same time, historical practices like endogamy did create detectable genetic patterns in many Jewish populations that modern DNA tests can identify. Another false narrative about Jewish genetic history being promoted revolves around the Khazar Hypothesis, to portray modern Ashkanazi Jews as impostors. The most famous version of this theory suggests that Ashkenazi Jews descended primarily from the Khazars, a Turkic people whose ruling class converted to Judaism in the 8th century. This theory gained popularity through Arthur Koestler's 1976 book, The 13th Tribe, but comprehensive genetic studies have largely debunked it. Multiple genome-wide studies have shown that Ashkenazi Jews have substantial genetic ancestry, shared with other Jewish groups and Middle Eastern populations, inconsistent with primarily Khazar origins. While some minor Central Asian genetic contribution cannot be ruled out entirely, it represents at most a very small component of Ashkenazi heritage. More broadly, genetic studies have consistently shown that despite centuries of living in diverse regions across Europe, North Africa, and the Middle East, Jewish populations maintain significant genetic connections to each other and to the Middle Eastern region where their history began. This doesn't mean modern Jews are genetically identical to ancient Israelites. All populations change over time through admixture and natural selection, but it does suggest substantial genetic continuity alongside cultural and religious traditions. As DNA testing becomes increasingly common, many people with no known Jewish ancestry occasionally discover Jewish heritage in their results. This reflects the complex history of Jewish communities, which sometimes included conversions, hidden Jewish practice, as with the conversos during the Spanish Inquisition, adoption, or undocumented relationships. For some, these discoveries prompt exploration of previously unknown family history and even reconnection with Jewish culture or religion. The field of Jewish genetics continues to evolve with new technological advances. Ancient DNA analysis is providing direct evidence about historical Jewish populations, rather than relying solely on inferences from modern groups. For instance, DNA extracted from 2,000-year-old remains in Israel has shown genetic similarities to both modern Jewish populations and other Levantine groups, providing direct evidence of genetic continuity in the region. So when you see Jewish on a DNA test, you're glimpsing a complex story of a people who maintained cultural and religious continuity despite displacement across continents. In the end, what makes the Jewish genetic story so fascinating is precisely this interplay between biology and culture.